Hi all. So the next set of instructions that we're going to introduce today are the counters. So we have count up, count down, or one that's a combined count up and down. So as always, I would encourage you as your first reference to use the reference manual, the general instructions manual. And looking at the table of index over here, I'm just going to skip to counter instructions. And so it looks like that's starting on page 269. And you can see, just like always, overview of the instruction, table that shows what the different inputs and outputs are, and remember, most importantly, or really importantly, is what data type each of those will be. And that's key for us today because up until now, pretty much everything we've done has been a Boolean data type. But now you'll see that a number of the parameters, so the program value and the current value, are double integers. So not just 1 or 0, now it's going to be a variable that we can change. So I encourage you to pause the video here and browse through these pages from 269 through a little past 273 there to go over the different types of counters we have. So go ahead and read those and then start the video again. Okay, so hopefully you read through that. I'm going to leave that open as a reference, but start up Connected Components Workbench. Encourage you to do the same so you can follow along. In talking to a few of you this week, I just wanted to encourage you in general to have Connected Components Workbench open, and if you can, follow along as I'm creating these example programs. Since you've got the video, you can pause it and go back, rewind, watch a part again if it's not making sense. But doing it while you're watching it is going to be a much more effective way of learning than just watching what I'm doing. Okay, so I'm going to start from scratch, even though I have my template. Just to remind you again the process there, I need to select my type of controller, and that'll be enough to create the program. Then I need to set up my controller a little bit, let it know that it has an LCD module is the main thing we need to set up here. And then I need to check my connection path or set it up since this is a new program. So all those things get me set up now. You can see my connection path updated there. I need to add a program, so I'm going to add a ladder diagram and I'll call it counters. Okay, again, just refreshing, reviewing. Before I start programming, I'm going to go in and add my aliases for my outputs that are I already know. So green lamp, orange lamp, red lamp. Let's see, then inputs, it says red, push button, toggle, green, okay, so now I have all of my I/O named. While I'm here, actually let's go into local variables and we'll create it there just so it stands out a little more. I'm going to create a new variable, and I'm just going to call John Dent. And we'll use that later on. So I just said that it's going to be a double integer, but I still need to actually select that as the data type, because while this name says Dent, that's just to help me remember what it is. That doesn't actually tell the PLC what data type it is. That's what this column does. Okay, so now I've created that variable. Let's go to the program. Okay, so we're going to start with our counters, and I will start with the count up counter first. I think it's the most intuitive. And as you recall, any instruction I want, I can get to from this instruction block under favorites. So even though I know I'll need an input first, I'm going to just drag that down here so that we can get started. And C, T, and then I'm count up. Okay. So looking there, you can see I have an input, the CU input, and if I go back and look at my counter, instruction. CU parameter is an input type. It's Boolean. And here's the description. What does it mean? When a rising edge is detected, so that's something we haven't really talked too much, that we've talked on and off, but some instructions matter not only if it's on, but is it just turning on or is it just turning off? So if you think about rising edge means the transition from false to true. And then you see on the next line there under false, it says falling edge detected. So when it's going from true back down to false, or basically when there's voltage being turned off on the input in this case, that's called the falling edge detected. And that can be useful in some instructions if you want to make sure it doesn't count multiple times per button press, that kind of thing. But basically what we're saying is when it goes true, it's going to increment my counter up by 1. And that's a key. I hope it makes sense why. If it just counted up when the button was true or when the input was true, it would count up as quickly as the program scanned, because as long as it was true, it would keep counting up. But counters, that's not the intent, to count scan cycles. The intent is to count transitions of your input or your bit. So what we really care about is I want to count when my bit goes from false to true. And that's what that verbiage there is explaining. So anytime that this CU input becomes true from a false condition, so that's that rising edge, it will increase the current value of the counter by 1. And so let's talk about these other these other parameters here. Reset, what that does is it will set whatever's in the current value, it'll just set it back to 0. So if you've counted up to 3 and hit reset, then it'll go back to 0. The PV, that's program value, that's basically like what you're counting up to. So if I set this PV value equal to 7, let's say, once I have counted up, so I've had 7 rising edges, then my counter would say, okay, I've met my preset value, and then this Q output would be true. Q is what says, yep, my current value equals my preset value. So I can just put a 7 in here, or I could put in a variable. So I could put in that John Dent there. For now, to be simple, we'll just start with a hard number in there. So I'll just put a 7 in there. So let's put in an input in front of the count up value. So that let's count the green push button presses. So each time my green push button goes from false to true, my counter should go up once. And then let's use the black push button. So let me just walk through what I did there again. You know, when I drag an instruction down here, it automatically brings up the variable selector. But in the case where I'm not adding an instructor, I'm wanting to edit a value, you just right click. Well, if you just click on it, you can start typing, or if you right click on it, you get variable selector. And I'm going to use my black push button as the reset, we'll say. Okay, and I am going to leave CV as empty right now. I could put in another integer if I wanted to, integer variable there, if I wanted that value to be moved into something else. But you'll see that we can just look at the value of that under our variables as well. And so lastly, let's put an output. Let's turn on our red lamp, let's say, when our number of counts is equal to our preset value of 7. Okay, so let's try downloading that. Okay, so it's downloaded, and you can see our program in here. Rung's blue, instructions are blue, so nothing has gone true yet. You can see that the reset is false. That's looking at my black push button I think I set there, and the current value is set to 0. So I'm going to hit the green push button once, and you can see that the current value incremented by 1. I'll hit it again and go up to 2, 3, 4, 5, 6, and you can see so far the output, the red lamp, is still not true because the Q, is our output for the instruction, it'll be true when the current value is equal to or greater than the preset value. So you watch when I hit 7 here, the red lamp turns on because now my current value is equal to preset value, and watch, the count can keep going up above the preset value. I mean, like if I hit the plus, it's still, how do I say it? It's, the number's not going up, but I'm still true, even it's not counting individual increments. So if I hit the black one now, and it reset to 0. So let's do that again quick. So I'll try to hit on 1, 2, 3, 4, 5, 6. So I got up to 6, and then one more takes me to 7, and the lamp comes on. Black resets it. So that's the quick overview of count up. So I would encourage you at this point to practice doing this with the count up instruction. Use one of your push buttons. Don't use the exact same one I did. Change things around to make sure you're comfortable with how you select the variables. So pause here, go ahead and do that. Make sure you're comfortable with how the count up works. And then once you are, come back and start the video again. We're going to expand this a little further, add a little more complexity to kind of see what we can do here. Okay, so hopefully you feel comfortable with the basic operation of the count up timer now. So what I want to do is add some complexity to how we use it. So instead of just having our count up value that we're counting up to always be 7, now I want to show how we could change that programmatically based on different inputs or whatnot. Later on you could do it based on some math instructions when we get into those. But for right now I just want to say we have one preset value if we hit one push button, or actually we'll use our LCD inputs, and a different preset that we're counting up to depending on another input. So I'm going to take the 7 away from here so that it's not always 7. And a couple kind of just housekeeping things we need to do if we're going to use the LCD display. As you recall, we have to always have an LCD instruction just to enable it. And again, hopefully you remember, we have a blank string by putting in 2 single quotes. Note that is not a double quote. If I put in a double quote, I still get the little warning sign. It's 2 single quotes. The single quotes basically encapsulate the string. So I'm just putting in two single quotes. It'll look just the same if I put in a single quote with a bunch of spaces and then another single quote. Let's go ahead and do that just for demonstration purposes, that it'll still look just like a blank, but it's really going to be showing a number of spaces in that case. Okay, so that enables the LCD itself, but then we also need a rung, hopefully remember, to enable the inputs on the LCD. So that was called key read. So I'll add that one in, and basically it can just sit down here. That's showing that's the instruction that I have to use to be able to look at the buttons on LCD. Okay, so now another instruction we're going to use is the move instruction. So if you want to pause and use your F1 help or look at the reference manual to remind yourself about move, and then restart it and see what we're going to do. Okay, so I'll insert a move instruction. And hopefully from your review of your literature, you understand that when the enable input goes true, it moves the value that's in the parameter I1, it moves it to O1. So in this case, I am going to say when this enable goes true, I want to move the value 7 into my variable that I'd created earlier called John Dent. Okay, and so if I left the rung as it is now, every scan, every program cycle, it would move 7 into John Dent. And that's not really what I want. I want it to do it when I press a button. So I'm going to put an input in front of the able, and that's one of our direct contacts, or examine if closed. And I'm going to look at, let's say the right key of my LCD. So when I opened up the variable selector here, or actually when it automatically did because I put in the instruction, it was already filtering automatically to Booleans. And that would be fine normally, but what I want this time is part of this key read instruction. So I had to clear that filter looking only at Booleans. So I'm going to do that again just to make sure that's stuck, what was going on there. So if I go to the variable selector, I'm in the right area. I'm under local variables, but it is automatically filtering to Boolean since my instruction type, right, the examine if true, examine if closed instruction, is a Boolean instruction. But the bit I actually want is part of this key read, so I had to clear my filter there. Scroll down, and let's say I'm going to use the right key for 7, and then I'm just going to copy this rung and paste it, and just change this. Instead of being right, I'm going to change it to left key, and then change this to 5 instead of 7. So now by pressing the right key, I'll set the value I'm counting to be 7, and by pressing the left key, I'll set it to 5. And what's going to happen is it's moving 7 or 5 into John Dent. So then here I can just also reference John Dent. And that's because it won't let you directly edit that preset value. Like if I put preset value in here, if I could do that, like it won't tell me I can't do it as far as selecting it. Watch here. So if I go to variable selector and look under the counter, I can see the preset value, program maximum value right there. I could address it just like that, but it'll error out when I build. Let's just build it to show you that. Illegal access to function block instance parameter. So it's saying, no, you can't do that. But if I go to the program and instead change that to John Dent, you can see John Dent is what's being used for that preset value. So functionally it's the same. I just had to create this intermediate variable for it. So let's try building that. And it was fine with building that. So I'm going to go ahead and download it. Okay, so a couple interesting things here. I've downloaded it, as you can see, but you'll notice if you're looking at my PLC, the red lamp is on. And that's because I didn't put any variable into the preset value yet. If we come back and look at local variables, John Dent, there is no initial value. So it just assumes a 0 for that when it's starting up. And so in this case then, since my current value is equal to my preset value, the red lamp is on. So this would be a good example where if I wanted to have it start at something other than 0, I should either establish an initial value under local variables here. I could plug in some number here. Or the other thing I can do is I could do another move instruction that used that first scan bit to always set John Dent to some other value. But that's fine. I'm glad we have this opportunity to see that behavior there. So now what I'm going to do is I'm going to hit the right key on my LCD and see if it changes what my preset value should be. So I hit the right key and it did. So if you look at it now, you'll see that the red lamp is turned off, and looking in the program, the preset value is now 7. So if I hit the green button 7 times, 1, 2, 3, 4, 5, 6, 7, my red lamp turned on. Now if I hit black, it resets back to 0. Now I'm going to hit my left arrow key, and you can see that the variable I'm counting up to, the programmed maximum value, is now 5. So by using those two move instructions, I'm changing the variable that is setting what my count up goes to. So this is how you, if you had a machine that you wanted it to run a certain number of cycles, this is a way you could switch between two different batch sizes. For example, if you wanted to do 12 or if you wanted to do 144, that kind of thing, you could programmatically change that by a push button. In just a day or two, we'll start using math instructions where instead of having to set it to a certain value, you could edit the value. Like the right key could increase the preset by 1 and the left key decrease it by 1. That's maybe a little more, not maybe, that's clearly more flexible than just having two variables that are the only two options. I can have either 7 or 5 under this example. So hopefully that makes sense about using the move instruction. So we've learned to count up, move, should be pretty familiar with LCD. The last edit I want to do on this before we look at one of the other counters is how could we display the value of the current value and what it's counting up to. And so that's going to involve using our LCD instructions down here. So I'm going to go ahead and disconnect so that I can edit it. I'm going to make my window a little bigger here. not quite that big. Keep it where you can see all of it. Okay, so I'm saying now I want to actually see my values as they edit up, or if they're counting up by the push button, or as I change what the value I'm counting to is. So that's pretty easy. We know that the one that I'm counting up to is always John Dent, and then the variable that holds what my current value at is this double integer that's part of CTU1. But remember, I have to have strings in here. So if I go to my variable selector and try to just go select, let's say and again, you can see it's filtering for string types as soon as I open this because it knows that's what it needs. If I clear that, I can select the current value of that, but you'll see it gives me the warning sign saying, hey, that's not the right kind of data. So hopefully you remember an instruction we used last week that helps us fix that, and that is the any to string data conversion. So if you just start typing any and then look for the any to string, and so here my input is going to be my non-string variable. So let's do CV first, and then I need to create some variables that I'm going to hold my strings in. So I'm going to come over to local variables, and I'm just going to create variables called line1, and call it a string. Okay, and then I'll create another one that says line2, and it'll be a string as well. And I'm only going to create the two because we're only doing those two pieces of data right now. So now if I come back to my any to string, I've got a double integer coming into it, and then I'm going to, let's say, probably I want to have the value I'm counting up to on line 1 and the actual current count on line 2. So this is current value, so I'm going to put that into my line 2 string. Then I'm just going to copy this rung, paste it, and I'm going to change this. Instead of looking at the current value, I'll look at the John double integer. That's the value that I'm counting up to, and I'm going to put that into my line 1 string. So let's just review those two rungs, and I'll just pull this rung down here so that line 1 comes before line 2. So this instruction takes the variable that's a double integer in John Dent, and up here we're on these two rungs right here, we're setting that to either 7 or 5, and it's moving it into line 1. Rung 5 takes the double integer value that's our current count value, that's this right here, and puts it into line 2. And I think it'll let me do that. We'll see if it gives me a build error. It'll usually let you directly access pieces of a counter as long as you're just reading it, not trying to write to it. So here I can change this to be line 1 and change this to be line 2. Okay, let's try building that and see if I have any issues. Nope, so I'm going to go ahead and download it. Okay, so it's downloaded, and before I click yes, I just want to point out on the screen here we have our default LCD screen right now, and as soon as I click yes, if we got things right, we should have our current value and our programmed value. And again, since I didn't set an initial value, they should both be at 0, and our red lamp should be on. And that's exactly what happened. They're both at 0, red lamp is on. So let's let the program get online here so we can watch what's going on. So now I'm going to hit my right key on my LCD, and that should change the value that I'm counting up to be 7. So my red lamp should turn off, and it did. So if you can, hopefully you can see on your screen there, top line says 7 and the bottom line says 0. So I'm going to hit my green. Actually, before I do that, I'm going to hit left key, and that should change my value that I'm counting to 5. You can see there. So I'm going to count up 1, and now you can see my current value on line 2 is counting up each time I hit the green button until I get to 5 and the red lamp turns on. If I hit right key, it goes to 7. Okay, so that's all behaving as we would hope. I'm going to disconnect and make one change here. Let's go to our initial our variables, and it's John Dent that we're counting to. So I'm going to put in an initial value of 3, and then I'm going to quickly download that. Okay, and so once again, let's watch the screen as we move into run mode. This time we should be counting up. We should not have the red lamp come on immediately, because we should be starting with a program maximum value of 3 instead of 0. And you can see that the top rung is 3 now, and our lamp is not on. So if I just start counting up right now, I get to 3 and I hit my red lamp. If I reset, I'm still counting up to 3. Keep resetting, but as soon as I hit one of these other keys, if I hit right key, for example, to go to 7, there's no way I can get back to counting to 3 with the way my program is right now. That's only the initial value set to 3. I don't have a way with my I/O in my program that I have to switch between 3 and any of the other values. Okay, that's good for this version. Let's take a break, play around with that, modify what you're adjusting to, change your inputs you're using, make sure you feel comfortable with count up, move, any to string, LCD, the local variables, and once you feel comfortable with that, start again and we'll move on to the next counter. So let's open the reference manual and look at our next style of counter, and that would be the countdown timer. So pretty self-explanatory. Before, we put in a programmed maximum value and we counted up to it. Now we put in a programmed maximum value, PV again, and we count down from it. So the only thing that really changes here is, instead of a reset to go back to 0, we have a load that we use to set what we're counting down from. So before, we automatically would reset with that single Boolean. And if you look, load is a Boolean, so it's not a value that we're loading into it. The value would be the preset value, or the program maximum value. So looking at the instruction here, load says load verifies the PV value against the countdown value. And so if you set it to true, it's going to basically set the current value back to the programmed maximum value. So let's go ahead and stick one of those in. So we'll disconnect. Let's get rid of the up counter, and I'll add an instruction for CTD, countdown. Oops, hit it one too many times. Okay, so here now what it's going to count, and if we go back and look at the instruction again, the CD, it counts down, and what I wanted to look at and just remind you about, it counts down on a true. So it's the rising edge detection that it counts down. So if I press and hold the button, it will count down as soon as I press it, because it's looking for the true. And then as far as false, the falling edge, it'll stay the same. It doesn't increment on falling edge, only on rising edge. Okay, other than that, I think most of the parameters are pretty much the same as before. Before, our output went true if we were greater than or equal to the preset maximum value, and now the output will be true if we're less than or equal to 0. We're just opposite end of our count number line. Excuse me. Okay, so let's start with, like we did before, just a fixed number that we're going to use for load. Oh, and see, I put it in the wrong spot. Remember what I was saying, load is the Boolean that will load it, and preset program maximum value there. Okay, so I'm going to say green is my count, and then I'll use black again. So I'll just right click to get my black push button. So anytime I hit the black push button, it will reset my current value to 9, and then we count down from there. So just kind of refresh what happens with this counter. Anytime CD goes true, it's going to take away 1 from the current value. when you first turn on the counter, first program scan, the counter value will be set to whatever the programmed maximum is. And then each green true transition will take one away from that. So if I start at 9, hit the green push button twice, I'll have 7 at my current value. If, while it's at 7, I hit the black push button, that will load the programmed maximum value into the current value again. So basically it resets the counter back up to 9. So let's just download, let's see what else here, anything else. So basically these two rungs they're fine to have in there, but they won't actually do anything right now because I'm not using John Dent in my counter. So let's download that. Oh, I must have missed something in the transition there. So let's look at the error. So somewhere in that one of those blocks, I still referenced the count up counter. I must have somewhere in my any to string, I bet. Yeah, so right there, I was still looking at the count up variable. So let's just change that while I'm here, and we'll watch the count down counter. Okay, and since we're doing that, I guess, let's see if it will let me look at the preset value of that one, clear that. I'm not sure if it will or not. So let's try building that. Yeah, it didn't. Okay, so we'll just go back and take that one out. Okay, but this one will let me in my local variable filter that to counter. Let's see if that one it'll let me. Nope, same thing again. Wait, that should be readable. Well, so you can see I would have to do the move it into another integer that I could actually read if I wanted to do that. So we'll just take that out for now and download it. Okay, so it's downloaded and I'm online. And you'll see, if you're looking at the PLC, the red light is on right away because I haven't pressed the black push button yet to load my preset value. So right now the count value, the current counter value, is 0. And we said that on a countdown counter, the output will be true as long as the current value is less than or equal to 0. So now I'm going to hit the black push button to load it. And you can see it went true there for a moment. My current value is now set to 9. So if I hit my green push button, it'll count down from 9 with each button pressed. You can see on the screen it's updating the current value. So once I get down to 0, the red light should turn on again, and it'll stay on until I hit black push button, which once again loads the programmed maximum value into the current value. So that's a down counter, and you'll use both up counters and down counters quite a bit. So go ahead and pause here and practice using, as an exercise, this isn't to turn in, but just for you to practice and get the hang of it. Why don't you put in a down counter that uses the red push button to count. So I want you, that'll be a little different since it's normally closed. Play around with so that it counts down when you push the red push button. If you start playing with it, it might, depending on which instruction you use for an input, direct or reverse, you might see that it actually counts down when you release the red push button, depending on what you choose. So that's a good exercise to practice using, figuring out, do I want to direct, or what we also call an examine if closed contact, as the input to my down counter, or do I want to reverse the examine if open type contact? So use the red push button to count, and how about use the toggle switch to load a value in, and then for now you can just use a hard-coded number like 9 here for your program maximum value. So practice doing that using your red push button count, toggle switch to load, and turn on your green lamp when you have counted down to 0. Okay, that's it for this lesson. I'm going to put an assignment in my MHCC that after you've watched this video, I'm going to have you create a program that uses counters, and I'm actually going to have you use the one type of counter that I haven't covered yet. That's the count up down. So if you're looking in your reference manual, it's the third one in there. And this is basically a combined up and down counter. So you'll see it has two inputs, a count up and a count down. So if you pulse the CU, your current value will go up. If you pulse the CD, your current value will go down. So you'll see it has basically all of the inputs of a count up and a count down just put into one instruction. So I want you to practice using your reference manual or your help, and practice playing around with that to get it to behave as per the assignment that I'll put in my MHCC. Okay, thank you. I'll talk to you guys tomorrow.